This is Lalo.
And this is Ramses.
And our partner is Isabel. She's recording. We will be discussing nuclear chemistry.
What is nuclear chemistry?
Nuclear chemistry is the subfield of chemistry dealing with radioactivity, nuclear processes, and nuclear properties.
Who are the scientists involved in the nuclear chemistry?
Well, first we have Henry Packard.
He accidentally discovered radioactivity.
In 1896, he expanded the field of chemistry to include nuclear changes when he discovered that uranium emitted radiation.
Mary Skłodowska Curie and Peter Curie began studying radioactivity and completed much of the pioneering work on nuclear changes, discovered the radioactive element radium and polonium.
And the next person we're talking about is Frederick Soddy. Frederick Soddy, in 1902, the theory radioactivity is the result of natural change in the slope of one element into an isotope of different element.
William Röntgen, 1895, discovered X-rays.
Ernest Rutherford
Radioactivity decay can be described by a simple equation, half-life.
coined the terms alpha, beta, and gamma rays.
Converted nitrogen into oxygen.
Rutherford model of atom.
Irene Juliet Curie married Curtis' daughter.
He created artificial radioactivity.
Bombarded boron with alpha particles to make neutron 4 isotope nitrogen-13. Isotope emitted positron.
He bombarded aluminum and magnesium with neutrons to make new radioisotopes.
Brojan, 1924, suggested that light waves also act as if they had particles properties, so particles such as electrons should have some wave particles.
Wait, why'd you say that? Skrodeniks, 1927. He realized that the similarities of vibrating systems such as violin and guitar strings contain both properties of wavelength and frequency.
Pauli, 1925, illustrated how all atoms can be signified by distinct quantum numbers.
Hayes-Bergs. He stated it was impossible to determine exact dynamical variables.
Callaway, 1932. Stop it! Discovered another type particle of significant mass in polonium bombarded with beryllium. Mass almost equal to that of proton but with no electrical charge, named a neutron.
Now we will discuss stable versus unstable nuclei.
In most atoms, the protons and neutrons found in the nucleus are held together strongly. The nuclei of these atoms are said to be stable. However, when the neutrons and protons in some atoms are not held together strongly, then they are unstable.
Isotopes that are unstable disintegrate to form other elements and are said to be radioactive, and are called radioactive isotopes or radioisotopes.
Bismuth, with a proton number 2 of 83, is the stable nuclei with the highest number of protons. All nuclei with proton numbers above 83 are unstable. They are radioactive.
What are the different types of radiation emitted during nuclear reactions?
First, we have alpha radiation.
Alpha radiation is the emission of alpha particle from atom's nucleus. Contains 2 protons and 2 neutrons.
When atoms emit an alpha particle, the atom's atomic mass will decrease by 4 units and the atomic number will decrease by 2 units.
Next we have beta radiation.
Transmutation of a neutron into a proton and electron, followed by the emission of the electron from the atom's nucleus.
When an atom emits a B particle, the atom's mass will not change, however, the atom number will increase by 2. And gamma radiation. And now gamma radiation. Gamma radiation involves the emission of electromagnetic energy from an atom's nucleus.
Small particles are emitted during gamma radiation, thus it does not itself cause the transmutation of atoms. However, it is often emitted during and simultaneous to alpha and beta radioactive decay.
Okay, moving to nuclear fission versus nuclear fusion. Nuclear fusion versus nuclear fusion. Okay. Atom's nucleus splits into smaller parts, releasing a large amount of energy in the process.
Firing a neutron at the nucleus of atom, the energy of the neutron causes the target element to split into 2 or more elements that are lighter than the parent atom.
During the fission of U-235, 3 neutrons are released in addition to the 2 daughter atoms. If these released neutrons collide with nearby U-232 nucleus, they can stimulate the fission of these atoms and start a self-sustaining nuclear chain reaction. This chain reaction is the basis of nuclear power.
As uranium atoms continue to split, a significant amount of energy is released from the reaction. The heat released during this reaction is harvested and used to generate electrical energy.
And nuclear fission.
That's a reaction in which 2 or more elements fuse together to form a large element, releasing energy in the process.
Fusion reactions release tremendous amount of energy and are commonly referred to as thermonuclear reactions. They both release large amounts of energy.
Do they have anything in common?
Yes, they do. They both release large amounts of energy. Now we will
talk about nuclear warfare.
Nuclear warfare is the nuclear fission weapons, atomic bombs.
Nuclear fusion weapons, thermonuclear weapons, hydrogen bombs.
They are boosted fission weapon, neutron bomb, and salted bomb.
First atomic bomb test released the same amount of energy as approximately 20,000 tons of TNT.
First thermonuclear or hydrogen bomb test released the same amount of energy as approximately 10 million tons of TNT.
A modern thermonuclear weapon weighing little more than 2,400 pounds can produce an explosive force comparable to the detonation of more than 1.2 million tons of TNT.
Only 2 nuclear weapons have been used in the course of warfare, both by the United States near the end of World War II. Uranium gun-type fusion bomb code named Little Boy was detonated over Japanese city of Hiroshima.
3 years later, on August 9, a plutonium implosion-type fission bomb, codenamed Fat Man, was exploded over Nagasaki, Japan.
Both bombings resulted in the death of approximately 200,000 people.
Fission weapons. Atomic bombs, all existing nuclear weapons, derive some of their explosive energy from nuclear fission reactions. Energy comes from the nucleus of the atom.
Massive tissue material, enriched uranium or plutonium, is assembled into a supercritical mass.
the amount of material needed to start an exponentially growing nuclear chain reaction.
Either by shooting one piece of subcritical material into another, the gun method, or by compressing a subcritical sphere of material using chemical explosive too many times in its original density, the implosion method.
Amount of energy released less than a ton of TNT, 500,000 tons of TNT.
All fission reactions necessarily generate fission products. The radioactive remains of atomic nuclear split by the fission reaction.
Many fission products are either highly radioactive but short-lived, or moderately radioactive but long-lived, and much are a serious form of radioactive contamination.
Fission products are principal radioactive component of nuclear fallout.
Most commonly used fissile materials for nuclear weapons applications.
Uranium-235 and plutonium-239.
Less commonly used uranium-233 and plutonium-237.
Fission weapons, referred to as thermonuclear weapons or hydrogen bombs, they rely on fusion reactions between isotopes of hydrogen, deuterium, and tritium.
Derive a significant portion and sometimes a majority of their energy from fission.
Fission weapon is required as trigger for the fusion reactions, and the fusion reactions can themselves trigger additional fission reactions. Thermonuclear bombs works by using the energy of fission bomb to compress and heat fusion fuel.
In the Teller-Wang design, which accounts for all multi-megaton yield hydrogen bombs, this is accomplished by placing a fission bomb and fission fuel, tritium, deuterium, or lithium telluride in proximity within a special radiation reflecting container.
When the fission bomb is detonated, gamma rays and X-rays emitted first compress the fusion, then heated to thermonuclear temperatures. The ensuing fission reaction creates enormous numbers of high-speed neutrons, which can then induce fissions in material not normally prone to it, such as the plated uranium. Each component is known as a stage, with the fission bomb as the primary and the fusion capsule as the secondary.
What are some benefits of nuclear warfare?
Nuclear means power. Political power that comes from owning nuclear weapons. A country that owns nuclear weapons is feared and respected. And what about the negative things about nuclear warfare?
Power negotiation. No one wants to argue with someone who holds the power of complete destruction. Nuclear weapons are one of the biggest reasons that nations do not want to go to war. Well, besides the fact that it can kill thousands of people and leave radiation in the air that contaminates everyone within distance, killing them eventually.
Are you against or for nuclear warfare?
I'm against.
Me too. In 1954, the Castle Bravo hydrogen bomb test the Pacific Proving Grounds contaminated the crew and catch the Japanese fishing boat Lucky Dragon. One of the fishermen died, and in fear of contaminated tuna led to temporary boycotting.
Oh, and don't forget that nuclear weapons is very expensive.
It's also very expensive and causes much harm to Earth. Nuclear weapons can't be the debris from nuclear weapons can be destroyed by natural causes.